और मुझे लग रहा है कि ज्ञान गंगा में, क्योंकि जब ज्ञान गंगा बहती है तो वी आर गोइंग टू अचीव अ गुड मोमेंटम। और मुझे यहाँ प्रत्यक्ष दिखाई दे रहा है कि द गॉडेस ऑफ नॉलेज इज here right now. Why? Because this lamp is illuminating. Further, I would like to thanks to our sponsors of this event, Southwestern State College and Kathmandu Model College. Without your support, it would not happen as it is going on. Thank you. Further, I have received two, three suggestions from Nepal side that they are saying that for academic committee, that should work for GLF should have some Nepalese members also. Further, one more suggestion is that to involve the government authority so that presented research papers will have policy implications. क्योंकि कागज पर जो चीज होती है उसको जमीन पर उतारना बहुत जरूरी है. And one more suggestion, it would be good to focus in the succeeding summits on specialization such as education, health, technology, agriculture, socio-economic and environmental, climate change. Good suggestion. Thank you. Mr. Anup Muni Bajracharya, Department of Microbiology, Bal Kumari College, Narayan.
Respected delegates, respected paper presenters, ladies and gentlemen, one and all. This is Anup Muni Bajracharya. I am engaged as a microbiology lecturer and head of Department of Microbiology in Balkumari College, Narayan, Chittoor. So first of all, I would like to express my sincere gratitude to the organizing team for giving me this platform to present my research work entitled Isolation and Characterizations of the Plant Growth Promoting Rhizobacteria from Rhizospheric Soil of Maize Plant of Bharatpur. Let's get through the introduction first. The major issues in today's world is growing global population. The population is growing day by day. The population is growing day by day in India as well as in Nepal. The huge population requires more amount of the food. And as we know that food is the fundamental needs of the human life. The food is essential for the human health as well as the society progress. Now, for the large amount of the population, how to manage the food, that is the most challenging issue nowadays. So to get more and more food, farmers are using different sort of chemical fertilizers, chemical pesticides and chemical insecticides to the field. Next please. So these chemicals which are using on the land, like the agrochemicals runoff from the land to the water bodies, may contaminating the water bodies and causing the various effect, badly affect the life on earth through bioaccumulation and biomagnification through the food chain. These pesticides also killing the beneficial natural insects, natural flora of the soil and decreasing the soil fertility. So if we use the chemical fertilizer, we have the several negative impacts, such as environmental pollution, soil degradation. There is an emission of the greenhouse gas also, and there is a negative impact of the health of the human as well as animals and plants. And it is costly for the farmers also. You can see in the picture that is the algal bloom, eutrophication, that is due to the excessive use of the chemical fertilizers. Now, what is the solution? What is the sustainable solution for this increasing global population? The solution will be the PCPR, that is plant growth promoting rhizobacteria. Now, these rhizobacteria are the bacteria which are around the roots of the plants, which helps the plants to grow effectively or efficiently, and they help the growth of the plant by variety of the mechanisms like phosphate solubilization, nitrogen fixation, signal for production, production of ACCD aminase, biofilm formation. So there are different sort of the merits points which can contribute for the plant growth and development. So we can use PCPR, the bacteria, as the biofertilizer. Now we have to avoid the chemical fertilizer and we have to go forward for the biofertilizer, because biofertilizer is the only solution for now to have the safe food for the overgrowth population of the globe. Next slide. My objective is to isolate and identify the plant growth promoting rhizobacteria from the rhizospheric soil of the Bharatpur Chitwan. And my specific objective includes to isolate the bacteria, to screen the isolates, and to determine the physical and chemical bioproperties of the selected isolate. And I also perform the antimicrobial susceptibility test of the bacteria. So in methodology, what I have done first is I have collected soil sample from 4 different regions of the Bharatpur. And these soil samples were processed for the isolation in 2 media, that is YMA and PVK, that is East Manipur agar and Prosbugska agar. So different screening tests, hydrolyzing enzyme tests, morphological characterization, biochemical tests, and physiological characterization has been done. So these are the sampling sites: Krishnapur, Rampur, Bassetti, Gondran, from where I have collected the soil sample. So first, in screening test, four tests I have performed: phosphate utilization, nitrogen fixation, indole-acetic acid test, and ammonia production test. And altogether I have isolated 79 bacteria, and among these 79 bacteria, because of the time constraint, I have only selected the 8 bacteria from there, and out of 8 bacteria, none of the bacteria can fix the nitrogen. That is one of the drawbacks of my research. Though some of the bacteria, like the 4 bacterial isolates, shows the positive for the phosphate utilization, as well as for indole-acetic acid test, there is a 2 tests, 2 positive tests. For ammonia production, there is 1 positive test. Regarding the enzyme hydrolysis test, all 8 bacterial strains shows the positive towards the cellulose hydrolysis, and in starch protease phosphate, you can see in the figure also. Urea broad growth, seam catalase, and TSI. And regarding the temperature tolerance test, all my isolates can tolerate 45 degrees Celsius temperature. So we can use these bacteria in the environmental condition also. At about 45 degrees Celsius also they can survive. So we can easily use these bacteria in the field as a biofertilizers. And then some of the bacterial isolates, the 2 bacterial isolates, BMS R1 and ZMS R13A, can even tolerate the salinity, and the growth is decreased on the increase of the saline concentration. And I have performed the antibiotic sensitivity test also, because the next major issues in today's world is the antibiotic resistance. And it has been said that by 2050, we are going to die through even the minor diseases like diarrhea and dysentery, because we don't have the antibiotics for the treatment. So you get bacteria which can be used as the biofertilizer. Some of them can produce the IAA, all are cellulose hydrolysis, but the drawbacks is that none of the bacteria can able to fix the nitrogen. We can use these as the biofertilizer, and we can apply in the field as a biofertilizer in the field. Thank you very much for listening. If any question, then please, I'm very happy to answer you.
Thank you very much, sir. And very useful reflections that we have made regarding the biofertilizers. One danger that we have in my mind, ammonia is a base. But in order to constitute ammonia in the form of the biofertilizers, it's to use as an acid as well. Under what conditions ammonia will act as an acid? Because if ammonia will act as an acid in the natural ways of the discussion and the research, then biofertilizers is also to be made in a very nice way. So please, my submission is only one. Under what conditions ammonia will act as an acid?
Use the organic acids or some sort of the acids, and these acids can neutralize the effect of the ammonia if that is present in the soil. So if the higher concentration of the ammonia is toxic to the plant, then these rhizobacteria can neutralize that toxicity through the acid production.
About the liquid ammonia, because liquid ammonia also acts as a solvent. अगर water solvent की तरह use कर रहे हैं, one dimension, and second dimension liquid ammonia act as a solvent as well. दोनों में अमोनिया का नेचर अलग अलग है. If ammonia in water, ammonia is a base. If ammonia in liquid ammonia, ammonia is a seed. Under what condition will act as a biofertilizer in our common use?